Okay, we are starting Chapter 8 today. Chapter 8, the title of it is Linear Functions. We are going to start off the chapter by learning what a function is, how to determine what a function is, and then throughout the rest of the chapter, we are going to learn different methods to graphing linear functions. So by a table, by x and y intercepts, using m and using b. So a lot of this is going to be new. And yes, this will carry over into Algebra 1. Ms. Wingrove will tell you she has taught graphing to just about all the classes now. So it will definitely carry over the same type of graphing. Math is going to repeat itself a lot. The point of the spiraling math books is so that you remember and retain it for when you get to the advanced, more of the advanced classes. So here's just some examples of graphs. We will not graph anything that has 4 graphs on it, but you could. We will graph some linear functions that have 2 equations, which is called a system of equations. The 7th graders are doing that now, so you'll definitely focus on more of that next year. Okay, our objective to 8.1 is to use a graph to represent relations and functions. So we are going to use a graph to represent relations and functions. And I will not take points off if you don't write the objective, but just so you know what we're going to do with this lesson. While some of you guys are writing that, your Chapter 7 test, if you finished it yesterday, I'm sure you noticed they are in the grade book. Yep, I put them in when I got home yesterday about 6 o'clock. I was actually sitting outside. It was so nice. I put them in the computer. So they're all in there. I will pass them back all tomorrow so that the people that finished today, I can finish those up. And we'll definitely go over them at the beginning of class. The average so far is a 93%. I thought I made that test hard. Apparently not. I don't remember what you all got. What did you say, Drew? Yeah, so the average will be higher, is what you're saying. No, we're going to say the average is going to be higher. There was one over 100%, so there was one 106%, and there were 200%. And lots of A's. Shane got the 106%. You did. I can't remember who got the 100. I think Nathan S., you got 100. I can't remember. All right, sorry, side note. Okay, first definition. Check on the grade book when you get to school. They're all there. Relation. So what is a relation in terms of graphing and in terms of a function? It's a pairing of numbers in one set, in parentheses, the ordered pairs. So a pairing of numbers in one set is a relation, which you could also say that the ordered pairs are a relation. So we're going to use the term relation to determine if a set of points is a function or not. Domain, I'm sure you've heard of domain before, are the x values in a relation. I wrote underneath domain independent because independent is also a term that we use for the x values in a relation. So domain and independent both mean x values in a relation. Bless you. Range are the y values in a relation. And then I wrote underneath it in orange, dependent, because range also means dependent. It's the y values. Before I move to the next definition, does anyone know another name for range or another name for domain? Neil? Good. Awesome. We're going to go in. Yeah, we're going to get into more detail about that. Yes. And next year, and in 9th, well, actually, just next year for you guys, you will talk more about independent and dependent based on scenarios to linear functions. Not this year, but next year we will talk more about that if I have you next year. So yes, you will see this over and over again. If you, oh really? All right. Oh, sorry. That's why I need names. My fault. When you girls are done, you can just put it on my desk. So anyway, we'll learn another word for domain and range in a little bit. Is it okay if I move to the next screen?
Yes.
Okay, input is another name for domain and independent. Input is each number in the domain. It's the x values. So input is each number in the domain. It's also the x values. Output is another term to describe each number in the range, which are the y values. So output each number in the range, y values. And this is what the function man will help us with. Bless you. Chloe, did you get some of it done? Okay. You all right? Sure. All right, so here's the function man. Okay, so I want you to think of our function man as these are the input values, which are the x values. These are going to be the output values, which are the y values. So before I go to the next screen, without looking in your notes, what's another name for input? Camille? Good, domain. What's another name for domain and input? Jackie? Oh, I thought that was your hand. Drew? What? Nope. That means y. Right? Good, independent. So input, independent, and domain are all names for the x value. Okay, what about output? What's another name for output? Ben? Good, range. I want you to think of the word range. You know how the G on range has a tail? Kind of goes below the line. Think of y, how y has a tail. It goes below the line. So range, let me write it up here. The G has a tail. I'll make it really long so you get the point. Just like y has a tail. So that's one way to remember range goes with y. Domain does not have a tail and neither does x, so they go together. And then the other term is dependent, okay? So here's the function man, so here's what we're going to do. I want you to tell me what you think is happening. So Kevin, I need you to come up here. Yep. I need you to take that number 4 and put it in the function man's arm. Okay, so a 7 came out. So Nathan M thinks adding 3. Okay, you can leave it there for now. Okay, have a seat. Okay, Skylar, come on up. I want you to stay in control so the function man likes you guys. Okay, Skylar, pick either the 2 or the 5. Go ahead and put one of them in. Wow, magic. Awesome. Thank you, Skylar. Okay, so what do you think happened? Camille? Good. You think add 3. Okay, so there's an option. Amberly, come on up. I want you to take the 2. Go ahead and put the 2 into the function man's arm. Kind of sounds weird. You just got to, yeah, there you go. It's all right. It's a little sensitive sometimes, the smartboard. Maybe you're, oh, how's it going in there? Okay, try it again. I don't know why that's happening. There you go. You got it. A little more. Okay, good. She put a 2 in and 5 came out. So give me a head nod. Do you all agree it's plus 3? Okay, so here was the point of that. So 2 was the input, and which is your x value, and the output was 5. That was your y value. Okay, so what is the role of the function? Well, you guys said plus 3, and that is correct. So if you move his hat, he tells you what it was. This is a very simple function where the pattern is you're adding 3 from x to y. In other words, from the input to the output. This will make more sense after we do some equations. Yep. Okay, Nathan S., come on up. Okay, you pick any of the numbers, go ahead and put it into the input, which is your x. So 8 is the x value, which is your input, and then a 5 comes out. Thank you, Nathan S. So what could happen here? Jackie? Yes. Okay, good. So it could be -3. Greta, come on up. What'd you say? If not, I'll pull it down for you. Put your arms up. You can get it. There you go. You got it. Okay, so 5 is the input. Good. 2 is the output, which is your y value. So what was the pattern, Drew, on that one? Good, -3. Josh, come on up. Go ahead and take the 7. It's just hard to press sometimes. You guys aren't used to that. There you go. Awesome. Here's a little trick, Josh. Come over here and pull the 4 out. There you go. Thank you. Okay, so that one was a 4. Do you think the pattern is still -3? Neil?
Yes.
Yep, same thing. All right, so let's move it, Pat. And there it is. So again, a very simple example of what is a function. There's not more on this slide, but I did, when I went to one of those math conferences that I go to, this was one of the tools that we received. So I have more stuff that goes with the function man. So yeah, I'll bring some more stuff in at some point and put it into your smart board. I thought it was kind of neat though for input output. Okay, back to our boring note packet, right? Okay, example 1. The input-output table shows temperatures over various increments of time. We need to identify the domain and range of the function, which is similar to what we just did. Identify the input and output. Okay, so Nathan asks, what are the domain values? Good. Domain values are x, so what are they in the table? Who can tell us what they are in the table? Alexis? Good. 0, 2, 4, and 6. There we go. The domain is x, which is the same thing as input, which is the same thing as independent. Okay, what are the range values in the table? Abigail? Good. The y values. And who can tell us, Ray, in the table, what are the range values? Awesome. How did you get 33? Good job. So 3 is added on to those y values, as Ray said, for every 2 x values. Now, I'm not going to go this far yet, but there is an equation that goes with that table that is the pattern. So the function man that we just saw, the 2 examples, were very, very basic patterns, +3, -3. A lot of times it will be x times something and then plus something. So again, we'll get to that eventually. Joseph? Go ahead. Do you remember? You want to explain it to us? For this one, you mean? Yeah, perfect. That's definitely how you explain that. Ben? How did you get that? Good job. I'm impressed. Is anyone else thinking that? Okay. Don't worry about it. We're getting to that. Ben, good job. We're getting to that. I'm not going to, right now, just know domain and range. Yeah, I'm not going to get into that right now. We'll get to that in this chapter. Actually, Miss Wingrove will probably teach you that, but we'll get to it. Okay, let's go to number 2, which is on the next page. If you want. Yep, are you done? That's fine. Yep, throw it on my desk. Okay, for number 2, Joseph, what are the domain values in the table? Good. 4, 7, 11, and 13. Drew, what are the output values? Good job. How did you get that? Why? What was the pattern with the y values? Good job. So initially it was +10, and then it was +15, and then it was +20. Okay, let's go to let's skip number 3 and 4. Let's go to the definition of function. Okay, so what is a function? Whenever we're graphing linear equations, they are going to be functions in this class. Eventually, you'll learn how to graph things in trig pre-calc that are not functions. So here's the definition of a function. For each input value, which means for each x value, there is exactly one output value. So for every x value, there is exactly one y value. So this is a one-to-one function is another way to say this. For every x value, there's exactly one y value. Right here, Ben. Make sure you write that down. For every x, there's exactly one y. And we could put domain and range in there as well. So you just need to remember input is x, output is y. Okay, this part's confusing, so I need you guys to make sure you're paying attention 110%. Ray, thank you. 110%, yes, exactly. Okay, well, hold on, let's look. So we have a list of input values and a list of output values. Here's one relation. 4 goes to 1, so I want you to put an arrow. Here's another relation. 8 goes to 2. And then the third relation, remember, that's like an ordered pair. We took one definition on that earlier. There's an x and a y that go together. So let me ask you this. By definition of a function, does each x value have one y value? Give me a head nod. What do you think? Does each x value have exactly one y value? Yep, you're all correct. So yes, this is a function because each input has exactly one output. So what I mean by that is none of these input values repeat. So you're good because this 4 goes to a 1. The 8 goes to a 2. This 2 goes to a 3. Each input value has exactly one output value. Now they're going to get harder. Gio. Nope. Don't worry about that yet. Nope. Hold on. I'm going to get to graphs. Hold on. I know what you're thinking about. Just give me a second. Actually, give me a couple minutes. Let's look at number 4. Okay, we have a list of input and output values. Let's draw an arrow for our relations. So we have 2 goes to 2. And then we have, again, 2 goes to, but now it goes to 4. 3 goes to 6. 4 goes to 8. Is this a function? Does each input have exactly one output? Nathan S., what's wrong with it? Awesome. Good job. So we have two twos here. I should say not different twos. We have 2 2s here. So we now have an input that goes to 2 different y values. That's not the definition of a function. A function is, every input has exactly one output. Since 2 goes to 2 and 2 goes to 4, this is not a function. And let me show you, hopefully this makes sense. The biggest reason that this is not a function is when we go to plot these points, 2 2 is right here. 2 4 is right here. 3 6 is about here, and 4 8 is about here. Does anyone know from a graph why looking at that as a graph is that not? And I know it's not perfect, but Josh? Good job. Gio, you want to say something else? If that was the scenario or situation, yeah, definitely. Nathan S., did you want to add something else? So basically, and I'm going to get to what the vertical line test is in a couple minutes, you cannot have 2 points that go through the same vertical line. That's basically the same definition as saying every x value has to have one y value. Every input has to have one output. You guys with me? Okay. Maybe I'm explaining this too much for you. I don't know. Okay, I want you to try number 5 and actually just number 5. So try number 5. I'll give you a minute. So is this a function? This one's a little tricky. Steve, what do you think? Okay, why? Good job. So 1 goes to 2. There's a relation. 2 goes to 2. 3 goes to 2. 4 goes to 2. Yes, it is a function because it's 1 to 1. We do not care that all of these repeat, because if we went to graph this, we would have a graph that looks something like this. That's a function. There's not any dots on top of each other. So the output values are allowed to repeat as long as your input values are different. Now, yes, there's exceptions to that. So that is a function. Every input has exactly one output. Neil. Good question. So let's say we have 1, 2, 2, and 3. And let's just say, Neil, that they all go to 4. So I want everyone to look at that. That's a great example. Hold on, I'm going to have everyone answer. What do you guys think? See some no's and some yeses. Shane? Good. You're right. It is a function because 2, 4 is the same point. So as Shane said, it's just going to be the same point. When you go to graph 2, 4, 2, 4, it's the same ordered pair or the same point on a graph. So yes, you're allowed to have repeats here. They're going to try to trick you and throw in repeats. Neil, does that answer your question? Okay. Okay, let's look at number 6 together. Okay, when they give you input and output values that are listed as relations or as ordered pairs, I want you to make a table. So make a table next to number 6 or wherever you have room. Let's take all the input or x values and list them in our table. So -2, 0, 2, and -2. Let's take all the y values and list them in our table. So they are -1, 2, 3, and -4. So if you list them in a table, I think it will help you so you can either draw your arrows or just look at it and say, is this a function? So here's all my arrows. So someone hasn't answered in a while or answered yet. What do you think? Is this a function? Greta, what do you think? Why? Awesome. So right here is what messes this up. So -2 goes to -1, but then at another point or another relation, -2 goes to -4. You cannot have the same x value going to 2 y values. So not a function. So not a function. It's not 1 to 1. Give me a thumbs up, thumbs down, thumbs down on that question. Okay. I want you guys to do number 7. So go ahead and make a table, and then I'm going to walk around. I want you to put yes or no. That's fine. Yeah, that's fine. If you do not need to make a table, that's fine. I just try to do that to help you if you're more of a visual learner and you need to see that, good. It's your call. I just try to give you tools. You guys can use whatever you need to. Good. So is it 1 to 1? Is it a function? Does every input have exactly one output? All right, you guys must think this is easier than last year. Joseph, is this a function? Michelle, why is it a function? Good job. Each input has exactly one output. Any questions on those types of problems? Okay, let's go to the vertical line test on the top of the next page. So vertical line test. Okay, well, I'm going to read all this. So basically, your vertical line test is still used to determine whether something is a function or not, but you can use this to determine whether a graph is a function or not. So again, the vertical line test is used to determine whether a graph is a function or not. So it says here, I think I got this from your book. If you can find a vertical line passing through more than one point of the graph, then the relation is not a function. Now, I kind of already showed you this because you guys were asking me questions that were related to this. So it's just like that graph I showed you. If you draw a vertical line and more than one point goes through it, not a function. I have a silly puzzle for you guys to do tomorrow as a warm-up that asks you to use the vertical line test. One of those riddles that's supposed to be funny, but it's really not. I know, I'm getting to examples. Hold on. Drew. Yep. I'm going to show you that. Yep. Okay, let me explain more with the examples. It'll make more sense. Okay, so let's look at number 8, and you have these right below your definition. So let's use the vertical line test. So the vertical line test is used to determine if a graph is a function or not. What it says is take a vertical line, draw it through your function. So let's draw some vertical lines. How many times does this vertical line touch the function? Or touch the line, I should say. Alexis. Good. It touches it once, so put a point right there. Let's draw another vertical line. How many times does that vertical line touch the green line, which is our equation? Peyton? Good. Once. So let's do this again. I can draw a million vertical lines, right? How many times do each of those vertical lines touch the green line? Evan? Good. Once. So is that a function or is it not a function? Alexis? Good. It is a function. So number 8 is yes, because it passes the vertical line test. Each vertical line touches the graph at one point. So yes, it is a function. Steve, does that make a little more sense? Okay. All right, let's go to number 9. Kind of looks like an ellipse. Let's draw our vertical line right here. You can draw your vertical line or start drawing them wherever you want. I would make sure that you draw a handful of them or just look at the graph and use your common sense. Drew, how many times does this vertical line cross the graph? 2 times. Here and here. So we can stop right there, right? That vertical line hits the graph or touches the graph more than once, so you know right away it's not a function. Your first quiz for this chapter will have questions just like this. And you could draw more if you wanted to. And they all cross it twice. Steve? No. The arrows, thank you for bringing that up. The arrows up here do not count. The arrow is so small when you do graph it. Of course, when I draw it, it's not. The arrows do not count. What counts is the actual graph part. Any other questions? Okay, Skylar, what about number 10? What do you think? Good, why? Good. Touches it more than once. Number 10 is definitely no. Gio, what do you think about 11? Good, why? Good, good. And ignore the arrows. I know that the arrows are really thick. That's just indicating that the graph goes on forever. Does anyone know what kind of graph number 11 is? Begins with a P, and you'll learn it next year. Well, depending on your teacher, but you should learn it next year. Gia? Or Q. Begins with a P or a Q. No one knows? A parabola? You ever heard of a parabola? Okay. So just in general, these are functions where the highest exponent is a 2. So like x squared plus 5x plus 6 would be a graph or equation of a parabola. all linear functions, which is your chapter, has an exponent of a 1. Okay, guys, Kevin and Drew, we're not on the homework yet. Okay, any questions or comments on these? Okay, in the last couple minutes, let me show you a couple things. This is not in your notes. So I want everyone to look at the smartboard. I'm going to shut the light off for a minute. So there are 6 types of functions. If you have me in algebra next year, I will have you memorize these. These are 6 types of functions that you will learn how to graph throughout your years in math in high school. So the first one, which is what we're focusing on in this class, is a linear function. This is a function. It is 1-to-1. The equation is y equals x for the positive, y equals negative x for the negative. Okay? The second type of function, and again, you'll see these again with me next year, is a quadratic function. Now, my drawing is a little bit messy, but this is a parabola. They are quadratic functions. A U-shaped graph, what looks to be like a U-shaped graph, is always a function. Okay, here's a third one. And these will be on Blackboard if you want to go back and look at them again. The third one is a cubic function. So a cubic function is, I always call it a squiggly line. Here's the positive cubic function. Here's the equation. Here's the negative cubic function. Here's the equation. Gio. Okay, so from left to right, if it's going down, it's negative. From left to right, if it's going up, it's positive. And we'll get into more of this next year, as long as I have you guys in algebra. If not, eventually you'll learn how to graph these. I think it's, Ms. Winger, was it trig, pre-calc, or algebra 2 that they learned how to graph these? That's what I think too. So eventually. Josh? It's not. It's just a bad drawing on my part. As you go this way, Josh, and for everyone, it keeps going more to the left, more to the left. You know what I mean? So it keeps going further out as it's going up. It's just very difficult to draw that without it looking like it's really wide. Good question. So yeah, it's not really an exact straight line. Okay, another one is an absolute value function. This one looks like a V. Nathan, I'm just make sure you're not doing that right now, okay? It looks like a V. It's a regular V and then an upside down V. This is also always a function. An inverse function, and I'm not going to get into this right now. The reason it looks weird is there are restrictions here and here, or boundary lines that you cannot have the graph touching or crossing. So that's why it looks like that. Drew? Why? That's one of the reasons. Yeah. So there's our inverse function, and this is trig pre-calc as well. And I think this is the last one, radical function or square root function. So y equals the square root of x, and then y equals the negative square root of x. And this one is also always a function. It passes the vertical line test, and it is 1-to-1. So what'd you think of that? Not bad? So you learned what a function is. You got to meet the function man. Did you like him? Okay, I need you to open up your pink packet to 8.1. And I want you to do all of them, please. There's only 13 questions. Okay, so on 8.1, numbers 1 through 4, you need to list the domain and range. 5 through 8, you are plotting points and then listing yes or no, whether it is or is not a function. Does anyone need to review plotting points from last year? Steve? Yep. All you're doing is listing domain and range. That's all you're doing. So list them all. Does anyone need me to review plotting a point? Give me a head nod. Anyone need me to review plotting a point? Yeah. So it's always x, comma, y. So let me write this up here. If x is positive, you go to the right. If x is negative, you go to the left. If y is positive, you go up. If y is negative, you go down. So if you look at number 5, -2, +2. Someone explain where we put that point. Raise your hand if you know. Where do you put -2 to? Nathan S.? Awesome. Good job. So for number 5, -2, +2, you go to the left 2 and then up 2. Put your point there. Okay. On the back, there's some more graphs, but they already give you the points that are there. And then there's 2 word problems, but really it's just asking you whether it is a function or not a function. Gia. You can just put yes or no. However, on 5 through 8, make sure you plot all the points. Okay, I know that you guys can tell by looking at the table, but I want you to plot the points. Ray, were you going to ask the same thing?